Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2305 fair distribution of cookies. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking? That we are given bag of cookies like this. We have different bag of cookies. One bag contain 8 cookies, another bag contain 15 cookies, so on and so forth. What we have to do is distribute these cookies among k students, and the student or child, the student will get the whole bag. Nothing like this will be done. For example, if a bag contain 8, it will not be divided into 4 or whatever it is, 5 3. Whole bag will be given to the student. So this we have to do. Now what problem is asking us is we have to give the minimum minimum unfairness. We have to return minimum unfairness. But what is unfairness? Unfairness is the max of total cookies obtained by k students. For example, if there are 2 students, this one has 30, this one has 31, then the fairness is max of 30, 31, which is 31. And but we have to return what? The minimum, because there will be many cases. Why there will be many cases? Because we take this cookies array. Let me write it for you. Yeah. So there are different combinations that we can take. For example, if k is 2, we can take 8 and 15 to one student and 10 28 to second student. This one has 23, this one has 38. So for this distribution, the unfairness is 38. And if we make something like this, 8 15 10 28, to first student, we give this to second student, and what happens? 25 33 and 28. For this distribution, the what it is, unfairness will be 33. If we take this case, 8 15 and 10 20, we take this case, this will give 31 and this will give 30. In this case, the unfairness is 31. There will be many cases, you can calculate that, but when you take the minimum of it, you will return 31, because it is the minimum unfairness. It is the minimum unfairness, not unsatisfaction. My bad, unfairness. So this we have to return. Now let's answer how we're gonna approach this. When I first read the question, this maximum and minimum, if there is maximum minimum present in a question, then it points to one thing: binary search. Binary search. Then I thought, how am I gonna do this permutation and then do a binary search? Then I look where I looked to the constraint, then I saw max, it is going length 8, and we have to do what we have to do in this given cookies array. What we are doing: picking or not picking or not picking. We are taking this decision, and which means there is recursion involved. And if recursion is involved and we have a constraint like 8 something, then there must be backtracking. That's how I went to this conclusion that this question can be done with backtracking. So let's see how we gonna do that. So what we will do is make a child vector of size k, and what we will be doing is we'll take a for loop which will start from I and less than k and I plus plus. And what we will do, we will give this child some cookies according to the position where the currently pointer is pointing, and we will do the backtrack call with this child position and whatever here cookies. Why we are doing this? Why we are doing this? And also I am taking the assumption that you know how to write backtracking algorithm. Basically what I mean to say is, you know how backtracking, what its template is written. It is always written like this: for inside that for we take decision, and also outside the for we have a base case. So first we are discussing the for. So what we are doing, we are taking decision. And why we are doing this, why we made a child vector? Because with single variable we cannot decide. That's why if there are k children, then we will have k things, then we will need to have k variables, then it is not feasible. So that's why I did this for because if there is a turn for 0th student, then it will, the cookies will store at 0th. If the 1th student turn is there, then that student will get the cookies. It is quite easy if we do like that. And after that, same thing, that's how we do it in what backtracking. We added something, then we subtracted again, because we have to make it original, and just return. And what else is base case? Base case is very trivial, because as you know, we are taking position, and if position is equals to cookies dot size, that it means we have taken decision for everyone, whether we take it or not take it, take it or not take it. basically take it or not take it, whether it will be given to the 0th or it will be given to the 1th or it will be given it to the 2th student. That's what I am saying. Why I told this, because if you have done DP type of question, pick and non-pick, that's why, to create similarity, that's why I told this. But basically what we are doing, that we are giving cookies to the student one by one. So for one cookie there are k choices. If there are n cookies, if there are n cookies, for one cookie there are k choices. For n cookies, k power n permutations we will have. So, and we have n is equals to 8, so no problem. So yeah, if it is equals to cookie size, then what we have to do, what we have to do when we have distributed, what we have to do, we have to find the max. And how we can find the max? If we have stored the distribution in this child vector. How? Very basic thing, using the for loop we'll find the max. After finding the max, what we have to do, we have to compare it with our current answer, because we have to find the min. So what we will do, we will compare it with the result. If this new unfairness, is it less than to the previous or not, that's we will be checking, and that's how we will approach this problem. Now let's see the code. It's quite basic. If you have done 2 or 3 problems on backtracking, it is quite easy, I would say. And also a dry run will be quite hectic, so that's why I'm not doing a dry run. You can do on your own. So let's see, this is the child vector that will store the distribution or the cookies given to that particular child, the backtracking call, and we are returning the result. So let's see what we are doing over here. The backtracking function, the global declaration of the result, this min, in order to find this minimum unfairness, when we have to find minimum, then we take max. Okay, so over here we will iterate over every children. That's what we are doing. And what we are doing, we are giving that many cookies to that children, then making the call. Why we are doing this? To get the permutations, basic simple thing. And after getting out of this call, we just take those cookies, because we have to do other permutations also. That's why we are doing it. And in the base case, as discussed, when we reach the end, what we do now, we have to find the maximum total cookies obtained by single distribution. Why? Because that is the unfairness. We have to find the unfairness. How we find the maximum among the distribution. So basic for loop, we find the maximum among the distribution, and after that we check if this unfairness, is it minimum? If it is, we update the result. If it is not, result will be same, and after that we return. Let's submit it and see if it is submitting or not. Yeah, it is submitting. Quite slow, but there is another better approach with binary search. You can do that on your own. For this video, you have to do what you have to do. Keep grinding. You guys are awesome. See you in the next one. Bye bye. And also consider subscribing to the channel, liking this video, and sharing with others. Bye bye.